Okay, so as I was saying now, um, for individual metals now that are using as electrode, they have their potentials. So let's now say, for example, we are using zinc and copper. Shey you get? We know that the reduction potential, the reduction potential means when zinc is being reduced from Zn2 plus to Zn. Shey you get? But don't forget, the guy needs two electrons to do that. So the reduction potential of this guy is, I've forgotten, let me check. For zinc, it is minus 0.76, minus 0.76. For copper, the reduction potential of copper, this thing is actually very, very trickish. The reduction potential of copper is plus 2 electron is what? To give you C is actually incoming. Let me check it out. Copper is 0.34 plus 0.34. But something is actually happening here that you need to get. So what I need you guys to understand here is that don't forget. Okay. I didn't say that initially. I didn't say that initially. Um, during during electrolysis, what happens to the anode? What happens to the cathode? Is the anode oxidized or reduced? Is the cathode oxidized or reduced? Yeah, I need answers on that. Yeah. Yeah, that's it. So this is it. So Kraho. So basically Kraho now. Cathode is reduction, anode is oxidation. Cathode reduction, anode oxidation. So that's just basically it. And from what we have here, this is reduction for what? I said cathode reduction, anode oxidation. That means, and this is reduction, right, for copper, which is the cathode. We are cool with it, there's no problem. But this is still reduction for anode. It's wrong. We have to change this to what? To what? Oxidation. And that will be you reversing this reaction. That will now be Zn giving me Zn2 plus what? 2E minus. That means the potential we're now having will now be what? Plus 0.76. So now that we have our copper is reducing, our anode is oxidizing. We now add the two together. Ignore this. Okay, we are not concerned about the first one again, just these two guys now. So when you add these two together, you have what? One, no, this is zero here. The one here after you add it, that's 1.1. It's 1.10 volts. For what? Plus, yeah, most always have the sign. For what? For Daniel cell, because Daniel is what? Zinc and copper. So that's basically that for that. So but for the question we now have here, so they gave us, let's look at what they gave us. So this is the combined reaction. You can actually get your answer from this combined reaction. So 3A2 plus is going to 3A, while 2B is going to 2B3 plus. But what they gave us is 2B3 plus is going to 2B. That means these two guys are not correlating, so you have to change this guy. So when you change it, this one will be what? Plus 0.64. When you add plus 0.64 to I'm coming. The standard EMF. Okay. They said this now said the standard EMF is this. So you add this one now. You add plus 0.64 to minus 0.42 plus 0.64 to minus 0.42. So you know what that means? That will be 0.22. Yes, I mean this thing is correct. Let me check the answer. Yeah, that's true. So that's just it basically. So it's just about the that logic. So they've already given us the reaction we have to follow that. The one that is undergoing reduction is this. The one that is undergoing oxidation is this. And they give us the reaction. So the reaction they give us is 3A2 to 3A, 3A2 plus to 3A. That's correct. We can use this. Then for this one, 2b to 2b3 plus, but they now give us 2b3 plus, so you have to change it for them. So when you change it, you also change the sign here, then you add it to what you have for this one that is constant, then you have your answer. That's as simple as that. So that's just basically this for this.